represent a real-world application as a linear function. So, to do this, we need two things. First, we need an initial value, because our initial value will take the place of the y-intercept, which we know in our equation is value of b. And we need the rate of change, because the rate of change is the slope, which we know in our equation is m. And then we can write our linear function as f of x equals mx plus b. So that's our goal. You started a new Twitter account with 8 posts on the initial day. Each day after that, you make just 3 posts. First, letter A, write a linear function to model your number of Twitter posts. Okay, so let's focus here on A. So, okay, we're doing our linear function. So f of x equals mx plus b. So what do we know? Well, I started with 8 posts on the initial day. That's my y-intercept, right? My initial starting point, my initial value. Then I make 3 posts each day. That's a rate of change. So each day I make 3 posts, right? 3 posts per day, rate of change. That is my slope. So my function is f of x equals 3x plus 8. That's A. Right, letter B. If you continue this consistent posting pace, how many total posts will you have after your first month, which we will use 30 days? So they're saying, what if x is 30? Now, I know that x is 30 because each day is what we're doing, which means we are talking about 3 per day. So x is the number of days. Okay, so if x is 30, I would say f of 30 equals 3 times 30 plus 8. So 3 times 30 is 90. 90 plus 8 is 98. So after 30 days, we would have 98 Twitter posts. That's what that means. Okay, let's look at another one. A painter notices there is a linear relationship between the number of rooms being painted and the number of gallons used. When 8 rooms are painted, 10 gallons of paint are used. When 10 rooms are painted, 12.5 gallons are used. Write a linear model to show this relationship. Now, this is a little more tricky because we don't have an initial value. We don't have a rate of change. So we need to find it. So we would say, okay, we know that when 8 rooms are painted, 10 gallons are used, right? So we have rooms and gallons. And we know when 10 rooms, 12.5 gallons. So we can find our slope, right? Remember that slope is change in y over change in x. I don't know why I made that line so long. Okay, so let's plug in what we know. 12.5 minus 10 over 10 minus 8, right? Change in y over change in x. So 2.5 over 2, and my slope is 1.25. There's slope. Now, to find our y-intercept, we're going to need to use an equation, right? And I'm going to use point slope. So y minus y1 equals slope times x minus x1. And I'm going to use the point 8, 10 because there's no decimals in that one. So plug in what we know. Y minus my y value equals my slope, 1.25, times x minus 8, right? Because remember, x1 and y1 are a point on my line. And we solve. So y minus 10 equals 1.25x, right, because I'm distributing. And 1.25 times 8 is 10, so minus 10. And now I'm going to add 10 to both sides. So y equals 1.25x. Y'all, that's my linear model. So I can write that as a function, f of x equals 1.25x. Okay, so we're going to use that to answer letter B. How many rooms can you paint with 16.25 gallons? Now remember, we had rooms, comma, gallons. So 16.25 gallons is my y value. So if I have the function f of x equals 1.25x, and I know that my y value is 16.25, right? Don't forget that f of x is the same as y, right? It's the output. So we would say, okay, great, 16.25 equals 1.25x. So to solve for x, I divide both sides by 1.25, and I end up with x equals 13. So that means we could paint 13 rooms with 16.25 gallons. Of course, this is assuming you're using all the same color. If you're changing colors in each room, you're probably going to need more than that because each room is just, 1 1/4 gallons, and that's just crazy. I love to paint. It's really fun.